Imagine a world where we're not alone in the universe, where life beyond Earth exists. Even the famous physicist and astronomer Albert Einstein thought this to be true as he wrote the law of relativity. For decades, we've searched the cosmos for signs of life, and our quest led us to the red planet, Mars. But today, there's a haunting possibility that we might have killed the only life we ever found on Mars nearly 50 years ago. The search for extraterrestrial life has been humanity's most profound scientific and philosophical endeavor. We've sent probes to distant planets, scanned the skies for alien signals, and peered deep into the cosmos for habitable worlds. But our closest neighbor, Mars, has always held a special fascination. The enigmatic red planet has long intrigued scientists with its potential to harbor life. With a thin atmosphere and a history of liquid water, it seemed like an ideal candidate. But our story takes a sad turn, back to when humanity was on the cusp of a groundbreaking discovery. In 1976, NASA commenced a program that was about to make history. The Viking landers were sent to Mars with a primary mission, to search for signs of life. These robotic emissaries carried a suite of experiments designed to detect living organisms in Martian soil. However, one particular experiment, known as labeled release or life bios, was an ingenious test that involved adding a drop of nutrients containing radioactive carbon-14 to a sample of Martian soil. If microbes were present, they would consume the nutrients and release radioactive gas as a metabolic byproduct. The results were astonishing. When the nutrients were added, the Martian soil exhibited a significant release of radioactive gas, suggesting the presence of living microorganisms. It was a momentous find that shook the scientific community and captured the world's imagination. With advanced technology and a more nuanced understanding of the Martian environment, current missions are equipped to search for biosignatures and subtle indications of past or present life. Perseverance carries a suite of sophisticated instruments, including the PIXL, Planetary Instrument for X-ray Lithochemistry, and Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, which can analyze the chemical composition of Martian rocks and search for organic compounds. The Mars Sample Return mission takes this pursuit to the next level. It aims to collect rock and soil samples from the surface of Mars and return them to Earth. These samples will undergo rigorous analysis in state-of-the-art laboratories, providing us with the most detailed insights into Martian geology and the potential for past life.
Assembly, Test, and Launch Operation Manager for the Mars Science Laboratory project. I'm coming to you from a clean room at the Kennedy Space Center, where my team is currently conducting the final functional test of the MSL flight hardware destined for Mars. Over here, we have our crew stage. The crew stage is comprised of a solar array, several guidance sensors, and a propellant system that basically gets the MSL spacecraft from Earth to Mars. Once we get to Mars, the vehicle will have served its purpose and we jettison it and it burns up in the atmosphere before we actually make first contact with the atmosphere itself.
Beyond the scientific quest, the search for extraterrestrial life carries profound philosophical implications. The discovery of even microbial life beyond Earth would revolutionize our understanding of the universe. It would suggest that life is not a rare anomaly but a cosmic phenomenon, raising questions about the prevalence of intelligent civilizations and our place in the cosmos. The story of the Viking landers serves as a cautionary tale, a reminder of the unintended consequences that can accompany our exploration of other worlds. It underscores the importance of ethical considerations in space exploration and the need to tread lightly on celestial shores. But as excitement swelled, skepticism emerged. Some scientists argued that non-biological chemical reactions could be responsible for the gas release. The debate over the Viking results raged on for years. In the end, the scientific consensus shifted away from the notion of life on Mars. The results of the Viking experiments were deemed inconclusive. The dream of finding extraterrestrial life was put on hold, and Mars remained an enigma. This made scientists wonder, and the big question was thrown: did we kill Martian life? An unsettling question asked nearly 50 years ago. Could the Viking landers, sent with the best of intentions, have unknowingly eradicated the very life they sought to discover? Here's where things get eerie. The Viking landers weren't sterilized to the rigorous standards we use today for missions to potentially habitable worlds. They carried Earth microbes with them, and it's possible that these terrestrial stowaways contaminated the Martian surface. Every spacecraft we send to another world carries a bio-burden, a hidden community of microorganisms. Despite sterilization efforts, some resilient microbes survived the journey through space. On Mars, conditions are harsh, but not entirely inhospitable to life as we know it. If Martian life existed, it would likely have evolved to survive in this harsh environment. However, Earth's microbes are not adapted to Mars conditions and would likely perish. So, here's the chilling possibility. When Viking's Life Bios experiment detected a gas release, it might have been witnessing the death throes of Earth microbes, not Martian life. We could have inadvertently wiped out the very life we were trying to discover. The truth is, we can't say with absolute certainty what the Viking landers detected. The ambiguity of the results still haunts us. Did we extinguish the only flicker of extraterrestrial life we ever found? One of the most compelling reasons for exploring Mars is its ancient water history. We've uncovered evidence of ancient river valleys, lake beds, and even traces of a once massive ocean. These findings suggest that Mars, in its distant past, had liquid water on its surface. The presence of water is a critical factor in the search for life. There is a popular saying on Earth, wherever there's water, there's life. Scientists are intrigued by the possibility that Mars may have hosted microbial life in its distant past when conditions were more favorable. There are also spikes in the detection of methane in its atmosphere. On Earth, methane is produced by both geological processes and living organisms. Could the same be true for Mars? The Curiosity rover, currently exploring the Martian surface, has detected fluctuations in methane levels. These fluctuations raise the intriguing possibility that Mars might still be geologically active or that some form of subsurface life could be releasing methane. Perchlorates are a type of chemical compound that we found on Mars. They can be both a potential resource and a challenge for future human missions.
Discovery of perchlorate on Mars had several implications. Immediate was the chemistry of Mars. Perchlorate itself is very stable, but the things that make perchlorate to go to perchlorate, like chloride to perchlorate, form very strong oxidants. And this might lead us to suspect that maybe the surface of Mars is very oxidizing and sterilizing for life on the surface of Mars. On the other hand, perchlorate is an energy source for bacteria on Earth. So subsurface on Mars, it's possible that there could be an ecosystem that thrives using the perchlorate that's formed in the atmosphere and then lands on the surface. So in that way, it's important for life. Secondly, if we ever wanted to set up a colony there, it'd be great. You have a ready source for oxygen, fuel, and then water. What else would you want?
Perchlorates can be used for rocket fuel production, which could be crucial for a sustainable Mars colony. However, they are also harmful to humans and can contaminate water sources. Understanding the distribution and properties of perchlorates on Mars is essential for planning future missions and ensuring the safety of astronauts. It's another piece of the Martian puzzle that we're still trying to solve. Fast forward to the present, and our approach to planetary protection has evolved. We now take extreme precautions to minimize the risk of contaminating celestial bodies. Our missions to Mars are meticulously sterilized, and strict protocols are in place. Despite the uncertainty of the Viking results, our fascination with Mars endures. We've sent a fleet of rovers, landers, and orbiters to the Red Planet, uncovering tantalizing clues about its watery past and the potential for life. While robotic missions have paved the way for our understanding of Mars, the dream of sending humans to the Red Planet is becoming a reality. Visionaries like Elon Musk and NASA's Artemis program are actively working on plans to establish a human presence on Mars. This endeavor poses a new set of challenges and ethical considerations. How do we ensure the safety of astronauts in the harsh Martian environment? How do we protect Mars from potential contamination by Earth microbes carried on human missions? The story of the quest for Martian life is one of fascination, mystery, and, at times, unintended consequences. The Viking landers, while pioneering in their mission, left us with more questions than answers. The enigma of whether we inadvertently silenced the only voice from another world still echoes in the halls of science. As we venture further into the cosmos, we must remember the lessons of our past and tread lightly on the celestial shores we seek to explore. But today, we prepare for future missions to Mars with a keen awareness of the potential impact of our presence on the Martian environment. Our pursuit of knowledge and the search for extraterrestrial life continue, but we must remain vigilant in our efforts to protect and preserve the mysteries of the cosmos. As we reflect on the past and the possibility that the future holds, Mars missions like Perseverance could finally answer the age-old question of whether life ever existed on Mars. If you enjoyed this video, please give it a thumbs up. Your support helps us reach more people with our content. Thanks for watching, and stay tuned for more updates.